Welcome back to Ancient Family History. If you've been with us on this journey, you know we've been diving deep into the origins of humanity, tracing the path of evolution, exploring the DNA of our ancestors, and uncovering the mysteries of who we are. Today, we're stepping into an even more profound territory, where science meets the essence of our being. What if I told you that encoded into our very DNA lies a connection to ancient ancestors, spanning hundreds of thousands of years? Let's delve into this. Before we embark on this journey, let's ground ourselves in the basics. DNA, or deoxyribonucleic acid, is the thread that weaves the story of life. Imagine it as a cosmic blueprint, a set of instructions handed down through generations, shaping every facet of who we are. These instructions, encoded in 4 simple letters, A, T, C, and G, form the foundation of our existence. They determine everything from the color of our eyes to the very way we think and feel. Each human carries within them around 20,000 to 25,000 genes. And yet, it's not just the genes that make us who we are, it's how the world around us interacts with them, shaping us in ways we're only beginning to understand. One of the most fascinating aspects of DNA is how it reveals the process of evolution through genetic mutations. For example, scientists have identified a mutation in the LCT gene, which allows adults to digest lactose, the sugar found in milk. This mutation likely emerged around 7,500 years ago among populations in Europe and is linked to the domestication of animals and dairy consumption. This adaptation provided a nutritional advantage in harsh climates where other food sources were scarce. To diagnose these genetic mutations, scientists use techniques like polymerase chain reaction and DNA sequencing, which allow them to identify specific changes in the DNA sequence. By analyzing genetic markers through these methods, researchers can trace the spread of mutations across populations, helping us understand how humans adapted to their environments and how these traits became widespread in certain haplogroups. Now, in this series, we're not just tracing lines on a map. We're uncovering the very essence of what it means to be human. Our goal is to follow the threads of genetic drift as early humans spread across the globe. How did these migrations give rise to different races, cultures, language, and even beliefs? How did wars and conquests carve out the world we know today? From the rise of empires to the blending of civilizations through both force and cooperation, these events left indelible marks on our DNA. But this journey isn't just about the past. It's about connecting those ancient stories to our present. We'll explore how these ancient migrations influence who we are, why we think and believe what we do, and how, despite all the differences, we're still bound by the same ancient threads. We'll also venture into the realms of consciousness and spirituality, seeking a deeper understanding of our shared human experience. When we look at ancient migration patterns, one key discovery is the spread of haplogroup M, which is prevalent in populations across South Asia, Southeast Asia, and Oceania. This haplogroup traces back to one of the early human migrations out of Africa, around 60,000 years ago. What's intriguing is that this haplogroup M is not only linked to early Homo sapiens, but also shows evidence of interbreeding with other hominid species like Neanderthals and Denisovans. For instance, Denisovan DNA is found in modern Malaysian populations, suggesting that these ancient hominids mixed with early humans as they migrated through Asia and into the Pacific. This genetic blending enriched the gene pool of these populations, influencing traits such as immune system responses and adaptations to local environments. By studying these genetic markers and their interactions with ancient hominids, we can better understand the complex web of human evolution. Now let's turn our gaze to 2 enigmatic figures, Y-Chromosomal Adam and mitochondrial Eve. These aren't mystical figures, but rather the scientific keystones that anchor our understanding of human ancestry. Y-chromosomal Adam is the man whose Y chromosome has passed down to all living men today. He walked the earth between 200,000 and 300,000 years ago in Africa. In a way, he is the origin of the lineage that spans continents and cultures. The study by Carmen et al. 2015, titled "A Recent Bottleneck of Y-Chromosome Diversity Coincides with the Global Change in Culture," dives deep into his story. Imagine every man alive today is connected by this thread, tracing back to a single individual. On the other hand, mitochondrial Eve is the woman from whom all humans have inherited their mitochondrial DNA. She lived around 100 to 200,000 years ago, also in Africa. The work by Behar et al., The Dawn of Human Matrilineal Diversity, explores her legacy. Her lineage endured when others did not, possibly through sheer chance or through events lost to time, and because of this, she is the ancestor we all share. The study of Y-chromosomal Adam and mitochondrial Eve have also led us to the concept of genetic bottlenecks. These occur when a significant portion of the population is wiped out, leaving only a few individuals to pass on their genes. For example, about 70,000 years ago, a severe bottleneck event is believed to have occurred, possibly due to a natural disaster like the eruption of the Toba supervolcano. This event reduced the human population to as few as 1,000 breeding individuals. The survivors' genes, including those of Y-chromosomal Adam and mitochondrial Eve, shaped the genetic diversity of all modern humans. Studying these bottlenecks helps us understand how catastrophic events can drastically shape the course of human evolution. But here's the wonder. They didn't live at the same time, and they didn't need to meet for us to exist. They are simply the most common ancestors in their respective genetic lines, part of a vast and intricate web that spans all of humanity. It's important to remember that Y-chromosomal Adam and mitochondrial Eve were not alone in their time. They represent the convergence of genetic lines. But our ancestors lived in populations of thousands. As the study Genetic Structure and History of Africans and African Americans by Sarah Tishkoff et al. 2009 reminds us. As human populations spread across the earth, isolation created genetic differences, a process known as genetic drift. Imagine people living in a great city, venturing into the wilderness and over generations adapting and evolving until they no longer resemble those they left behind. This is how diversity in traits like skin color emerged. Throughout this series, we'll follow these genetic drifts, tracing how they shape the diverse tapestry of humanity, while uncovering the profound connections that unite us all. Our story becomes even richer when we consider that early humans didn't journey alone. They encountered and interbred with other hominid species like Neanderthals and Denisovans. The study, The Genetic Legacy of Neanderthals and Modern Humans by Sankara Raman et al. 2014, reveals that traces of these ancient encounters still linger in our DNA. These interactions didn't just shape our genes. They shaped our history, culture, and the very way we experience the world. To trace these ancient lineages, scientists use haplogroups, clusters of similar DNA sequences that share a common ancestor. For instance, haplogroup L is predominantly found in Africa, while haplogroups M and N spread into Asia and Europe. The study, The Journey of Mankind Genetic Atlas by Stephen Oppenheimer 2003, maps out these migration patterns. These movements, adaptations, and encounters are the very threads that weave the human story. As early humans ventured out of Africa, they adapted to new environments, leading to the diverse physical traits and cultural practices we see today. But as the study Human Genetic Diversity and the Non-Existence of Biological Races by Lewitton, 1972 reminds us, race is a social concept, not a strict biological division. We are far more alike than we are different. While science guides us through the corridors of our evolutionary history, the concept of Adam and Eve still resonates with our spiritual and cultural imaginations. These stories remind us of our desire to connect with something greater than ourselves, to understand where we come from and why we're here. Another fascinating area of study is the genetic evidence of early human interbreeding with Neanderthals and Denisovans. For instance, modern non-African populations carry about 1 to 2% Neanderthal DNA. This genetic legacy affects various traits, including immune system responses. For example, genes inherited from Neanderthals have been linked to a heightened immune response to viruses, which may have helped early modern humans survive in new environments. Similarly, Denisovan DNA, particularly prevalent in Malaysian and Aboriginal Australian populations, includes genes that help with high-altitude adaptation as seen in Tibetan populations. These interbreeding events show how ancient encounters shaped our genetic toolkit, helping us adapt to diverse environments across the globe. In the scientific narrative, Y-chromosomal Adam and mitochondrial Eve are symbols of endurance, of lines that survived against all odds. They connect us to the distant echoes of our past, to the ancestors who shaped the world we now inhabit. As we close this chapter, remember that our shared ancestry is a story of survival, adaptation, and connection. From Y-chromosomal Adam to mitochondrial Eve, and through the countless migrations and encounters that followed, our story is one of epic wonder. We are all part of this grand tapestry, woven together by threads that stretch back to the dawn of humanity. In our next episode, we'll dive deeper into the journey of human DNA, exploring the earliest known tribes and groups that left their mark on our genetic history, from Neanderthals and Denisovans to Homo heidelbergensis and early Homo sapiens. We'll begin tracing the DNA and haplogroups that connect us to these ancient populations. We'll discover how they adapted, interacted, and laid the foundation for the diverse cultures we see today. This is just the beginning. Make sure to like, subscribe, and hit the notification bell to continue this journey through time as we uncover the deep connections between ancient human DNA and who we are today.